Oh, good morning. Thanks for tuning in for another Sprinkler Talk. This is episode number 38. Hope everyone can hear me okay and see my screen all right. So you should be seeing the purple Sprinkler Talk background. Just again, if you're new to the channel, so yeah, welcome and thanks for tuning in. My name's Andy and I work for Project Fire. Project Fire are based in Staffordshire in the UK, and we sell innovative and sustainable products for the automatic fire sprinkler industry. So this channel is all about automatic fire sprinkler systems. We go into lots of detail about quite specific, quite niche topics at times, and at other times it is more of a general kind of overview of other things, and today is one of those. So I'm talking about BIM, but this is going to be from a sprinkler point of view. I'm not an expert on BIM. There's lots of other really good videos out there on YouTube, etc., to watch if you want to know, the specifics of BIM or specific questions. Today I'll just be covering like an overview of what it is and sort of link it to both Project Fire and to the sprinkler industry as a whole. Again, if you're new to the channel, just we're on Blue Jeans at the moment. So yeah, Blue Jeans is pretty much exactly the same as Zoom. Very, very similar structure. There's a chat function. So yeah, I'll just ask you to keep your videos and your microphones muted. If you want to interact, that's great. Happy for that. If you just pop a comment into the chat, and then I can address that question or get back to you at another time. Okay, let's get going then with episode 38 of Sprinkler Talk, and we're talking about BIM, which is Building Information Modeling. So first of all, you've seen this screen before when I've spoken about MIS systems. Is my sort of disclaimer screen. I've already kind of said a little bit about that. So I'm not an expert on BIM. I've been to a few seminars on it. I've obviously read up a little bit about it. And I have had some involvement from a Project Fire point of view as far as developing our products into a BIM format, so we can export those to consultants and other interested parties to have our products available in a BIM format. So that's been my my sort of exposure to it. But as I said before, not an expert, and there's lots of other very detailed videos out there on BIM and other software that kind of integrates with it. Okay, so that said, what is BIM then? A good place to start. So here's a definition by Autodesk. Autodesk are the company that make AutoCAD, and they also make Revit. So Revit is a key tool in BIM. So it says building information modeling, or BIM, is an intelligent 3D model-based process that gives architecture, engineering and construction professionals the insight and tools to more efficiently plan, design, construct and manage buildings and infrastructure. So yeah, I quite like that definition. I think that's pretty good. So we're talking about a 3D model, yes, and when people think about BIM, I guess that's what kind of pops into people's heads, these kind of 3D models, this large very detailed, very complex 3D model of the whole building. But the point about it is that it's not just geometry. It doesn't just look nice. It's intelligent. So there's lots of information built into those 3D models. Okay, so the I of BIM stands for information. There's plenty of information that's crammed into all of these 3D models. And of course, that information there isn't just there for fun. It's there to make planning, design, construction, managing, infrastructure, going to make that really, make it sing, make it smooth, make everything kind of work together to create more efficient buildings. Here's another definition, this time from NBS. NBS seemed to be a sort of a national library, I suppose, of BIM information, and they also have their own sort of database of BIM files which can be used. So they say BIM, or Building Information Modeling, is a process for creating and managing information on a construction project across the project lifecycle. Okay, so that's key. Project lifecycle is a key term. Most of the kind of the tools that we used to use for construction were for the construction phase only, and kind of once the building has been built and been handed over, then all of that kind of stops, and now it becomes a sort of a lived-in building, and things become quite different. Well, the idea of BIM is that it's for the whole life cycle of the project. Carrying on, one of the key outputs of this process is the building information model, the digital description of every aspect of the build asset. Okay, so that's using quite kind of technical terms now. But yeah, the built asset is the building, is the project, and we have a digital description of every aspect of it. So again, that's kind of coming back to this idea of information. The fact that if we have a door, for example, in our BIM model, it's not just geometry. It knows it's a door. It knows what material that it's made out of. It knows whether it's a fire rated door and what the fire rating is. It knows what service and maintenance is required. It knows the manufacturer and the kind of model number. So let's say in the future the door is damaged. Okay, so we need to replace that door because it's a fire door. It's doing an important job. So we can click into our model and we can pull up that door. We know exactly what size it is, what specification it is, the model number, etc. And yeah, we can order a replacement door very easily. Moving on, this model draws on information assembled collaboratively. Okay, so again, we're not just coming from one source. There's lots of different services, lots of different engineers from different areas of construction coming together to work collaboratively on this model. Creating a digital building information model enables those who interact with the building to optimize their actions, resulting in a greater whole life value for the asset. Again, using quite kind of complex language here. But what we're talking about is efficiency. It is making it better. Rather than each service kind of doing their own thing separately, we're now working together. We can do better simulations. And in terms of cost savings, we can actually have a look at exactly how much materials is required in advance before we start the kind of building process. But I'll come on to some of those examples later. So there's a couple of definitions of BIM. Here's mine. Okay, so this is my much simplified definition of BIM. Adding more than just geometry into 3D object files that can be easily shared and integrated. So I guess I'm not really capturing, I suppose, in that definition, this idea of this larger building file. But yeah, from my perspective, that's what Project Fire, that's what we need to do, is we need to create these 3D object files with more than just the geometry in there. That is going to help to achieve all of those things that we put in those previous definitions that can be easily shared and integrated. You've probably seen these kind of graphs before. Certainly whenever I've gone to, say, look at BIM seminars and documents to do with BIM, that they've shown a kind of similar kind of a graph to this. So here we have BIM level 0, 1, 2, and 3. So what we're saying is that 1990s. Say I know that CAD was around in the 80s as well, but for argument's sake, we're going back to the 1990s, and we have CAD. Okay, CAD, computer aided design, and we have drawings. So we're leaving drawing boards behind. We're now moving to the computer, and we can create 2D object drawings. And they're really useful. They can speed up the design process. We can share them with other people. Once we've created the CAD file, we can take dimensions off there, and they're always going to kind of stay the same. Then in the 2000s, we have 3D design. Again, I know 3D design came in before that time, but I suppose we're talking about coming into the mainstream, and kind of the typical way of doing it switches to a 3D environment. We then have 3D models, objects, and collaboration. So there's just a picture of 2D design. So that's done using AutoCAD. You can see that's our zone check product there. So we've created 2D drawings, which again, and some people still want those. Some sprinkler contractors will ask for the 2D object blocks, so that then when they're then doing their sprinkler design, they can drag and drop these files onto their pipe, and they can put a little note next to it to say, this is an 80mm right-hand zone check, and the model number. So again, we're building in a little bit of intelligence into that, and we can check that there's space for that model within within the walls and the ceiling, etc. We can check that there's enough space for the zone check to fit. We've also got 3D files, so that this object here has been created in a program called Solidworks. So Solidworks is an example of a 3D modeling package. So this model has been created using an assembly. So so the flow switch, for example, is made up of the U-bolt, bolts, the lid, the electronics, the kind of the housing of it, and all that comes together to make one assembly. And then that forms part of a sub-assembly to make a larger assembly of a zone check, which also includes the pump and the angled valves and the manifold, etc. And again, that's really useful because we've got like a fixed impression of what the zone check looks like. We use this 3D model primarily for our data sheets, our instruction booklets, for our manufacturing processes. We can slice it open. We can make exploded views. So that's really useful to kind of illustrate different things about our product. You can do simulations on SolidWorks. You can do some calculation in terms of stress analysis and flows, but that isn't something that we've kind of tended to do. We just stick really to having the geometry there on file. And then we have sort of the introduction of BIM level 2, BIM level 3. So BIM level 2 is to do with collaboration, really. It's making those files available so that people can kind of work together. BIM level 3 has got these two words here, transactable and interoperable data, which means, again, the idea of sharing information. Those two words are kind of, in my head, they kind of mean the same thing. They're about making things easy to share information from one source to another. And BLM is Building Lifecycle Management. So again, we're talking about the whole of the building lifecycle. So putting things in to do with the service and maintenance routine, replacement components, troubleshooting, what happens, if this happens, then how are we going to go about fixing it? Kind of setting kind of reminders, I suppose. If something isn't serviced for a time period, we can kind of make the model sort of flag that up and say, I need to be serviced. So that's, again, this idea of level 2. Level 3 BIM is taking it to the next stage, building in even more information into the model. This is a question I suppose I've kind of written for myself, because I remember when I first was learning about BIM, this was sort of in my head, this word Revit. What is Revit? Is Revit BIM or is BIM Revit? So Revit is is a software program that is made by Autodesk, and it is designed to handle BIM files. It's designed to create this overarching 3D model, which is kind of the master model for the whole of the building. So, Revit is a program to use with BIM, but BIM does not equal Revit. BIM is more than just a software program. So BIM uses lots of different types of software to all come together to create this sort of flowing process. So yeah, Revit is a useful tool, but it isn't BIM in its entirety. Revit is become kind of the number one program to kind of handle that overall model, but it isn't the only one out there. But yeah, Revit model is not the complete picture. Another kind of acronym that we need to look at is IFC, which stands for Industry Foundation Class. So IFC is designed to be like an open source format for data exchange. So I've heard other people describe it like the PDF of BIM. So the idea being that you've got people working on one part of the project, people working on another part of the project. If they want to exchange information, then one thing that they could do is they could both access the same Revit model, but then you've got issues in terms of who's kind of got the master file, who's allowed to make changes and who's not. So this idea of sending somebody like a PDF so they can view it, they can gather the information that they need, they can suggest changes, which can then sort of come back to the master file. So yeah, for me, that's kind of what IFC is about. It's about this kind of idea of data exchange. So advantages of BIM. Now these advantages are quite similar to the advantages we looked at for modular construction. So advantage of BIM, speed of construction through fewer issues. So what I mean by that is that things never work perfectly, and they're never going to work perfectly in a BIM environment either. But this idea of getting onto site and then finding things aren't quite as we thought they were in the design process means that then problems need to be solved, and for problems to be solved it takes time. So the more problems we can find and we can fix in advance of getting to site, then the faster the construction is going to go. Speed of installation through planning. So again, just being more thorough as far as planning goes, making sure we know the route of every pipe. Arguably, we know the route of every single cable within that building and where it's going. Again, it means that we can be more efficient when we come to install it. Prefabrication is made easier because we have this kind of 3D environment to work in. We know what space we're going to be working with. One of the problems of prefabrication is being able to be confident that we can actually fit it into the building, because often these prefabricated units are big, just the kind of their nature. So again, BIM allows us to kind of plan ahead and think, okay, well, do we have access? What's the journey that this component is going to take through our building into its final location, so we can again be more confident that is going to work. Cost estimation and material savings. Again, this idea of, let's take an example of electrical cable, for example. We don't know exactly how much cable is going to be required, so an experienced electrician is going to give an estimate, and of course they're going to add a bit more because they don't want to be out of pocket about it. So they're going to sort of estimate and then add a margin to it, times it by 1.5 or something. With BIM, the idea is that we can be more accurate in terms of exactly how much of a material that we need, so we actually save on materials, and obviously that leads to cost savings. Better coordination between services. I mean, that's absolutely key. Know that from a sprinkler point of view, is that sprinklers and HVAC systems are often sort of fighting for the same spaces. Having a coordinated BIM model means that we can sort of discuss where things are going to go, we can spot clashes, and we can solve those problems before we come onto site, which is, say, down to an easy information exchange. Cost savings through a smoother project. I mean, that's pretty obvious. Delays cost money, so that the smoother a project goes, the more cost savings there should be. Space efficiencies, again, planning ahead just means that we can potentially be tighter with our space that we need. If we don't know, we're gonna estimate how much space we need, and we're gonna add a bit because we don't want it to not fit. So, say, being able to be more confident about the space that we have and fitting the products into the space, we can save it. Better handover to end user. So again, this is to do with in the kind of the pre-BIM days. I guess the construction drawings were there for construction, whereas now we can actually hand over this BIM model to the end user, and that's got all of that intelligence and all of that information already embedded in that model, which can then be referenced and used for the life cycle of the building. Let's talk about sprinkler design software for a minute. So there are various packages on the market for designing sprinkler head layouts. In my brief time when I worked in the sort of engineering side of Project Fire, when we were contractors, we used AutoCAD. We used AutoCAD in order to plan out our pipes and our heads. And that obviously created 2D drawings, which we could then submit to the normally to the M&E contractor. We would submit those drawings to them, and they would then say, "Yeah, we're happy with that." We get them signed off, and then we can pass them on to the installers, who can then actually refer to those drawings and install the heads. But there are other programs that offer better functionality. Such as AutoSprint, SprintCAD, Canute, Fire ACAD, and they all have the ability to calculate flow, to calculate pressures, to calculate the water discharge. They can do the FHC calculations in the background because they have been set up specifically to do sprinkler design work. Now, we can design sprinklers in Revit itself. So Revit has families, default families for pipe and for sprinkler heads, and also, of course, we can import additional pipe couplings, sprinkler heads. So we can design in Autodesk Revit. My experience so far is that not that many people are sort of taking them up on that option. They're using other programs, such as the ones on the screen there, and then exporting that into Revit. So the person that is kind of managing the overall BIM model has got access to the geometry from the sprinklers. The information, the kind of intelligent bit can be added to that model, but the actual design stuff is done in a different program, which is absolutely fine. Say as long as the coordination can take place, and as long as the intelligence is there in the model, that doesn't really matter how we kind of end up at that goal. Does Project Fire have BIM models? Yeah, of course we do. That's good. Glad you asked. So there's a few examples on the screen there. So our Revit models, so these are available as Revit families. We've got the vast majority of our product range already done. So you can see these models have been simplified because we could, remember I showed you the Solidworks model earlier on. We could have created Revit files that looked as good as that, But the problem is that they obviously come at a higher file size. And when you're doing coordination works in Revit, all you're really interested in is the very sort of basic geometry. You know, how long is it? How wide is it? How deep is it? So yeah, the models have been simplified to kind of save file space, but they're still recognizable as the models themselves. And then they are intelligent, so they know that they are a fire category. They know that they are sprinkler category. They know that they connect onto pipe work, and the pipe will sort of lock on to the ends. They've got obviously the intelligence of knowing what they are, who they were made by, what size they are. The zone checks I'm very pleased with. They've got parametric data in them. So there's one file for all sizes of zone check. And then you can just make that expand and contract, sort of get bigger and get smaller to fit onto the size of pipe that you're working on. So very, very easily, because it's kind of like in a drop-down menu. So yeah, I'm quite pleased with the way that worked out. Then with our fire pods, again, we've got the addressable system on board there. And again, that knows it's an electrical system. It knows how to connect onto the glands for the wires, etc. So yeah, I feel that we're ahead of the game there in terms of providing these BIM models with that intelligence. But of course, BIM is always moving forward, and we need to keep up to date with the latest standards, etc. If you'd like to download our BIM files, then please contact us. info@projectfire.co.uk would do fine. Or you can email me. You could email the Sprinkler Talk email. You could give us a call, of course. Any of those options, and then I will happily send you whatever files you require for your models. Okay, that's good. I hope you found that useful. I didn't get a load of people in the chat telling me that what I was saying was a load of rubbish, so that was that's encouraging. But probably some of the things that I said weren't quite right there. But say it's an overview of BIM. Do encourage you to kind of seek out other sources of information if that's something that you're particularly interested in. But I hope that was useful as a kind of an overview of what BIM is and how the automatic fire sprinkler industry is going to have to feed into that larger construction BIM model. Next week, we are looking at the latest sprinkler news. So again, this is something that I've done a few times in the past. So I'll just look at some of the latest stories, some of the latest innovations, standards, etc., and just go through and tell you about them. So yeah, hope you can join me next week for another Sprinkler Talk on the latest sprinkler news. As always, I'll just hang around and see if there's any comments in the chat. Thank you, Richard. Appreciate that. Andrea, thank you. And yeah, I'll see you next week. All right. Bye-bye.